From the previous video, you have seen that there are 4 patterns of drawing a mechanism. Recognize it one by one. Okay. First pattern we call nucleophilic attack. Why do we call it nucleophilic attack? Because the nucleophile actually attack an electrophile. All right. Look at right here. So you should be able to tell that the bromide is your nucleophile and the carbocation in the middle, that's your electrophile. Right. Now you're going to draw an arrow from bromide to carbon, to the carbocation. All right. So notice that I draw from an atom to atom, or more specifically, the lone pair of the nucleophile right here to an electrophile. All right. That's how we do it. Now, this is the case of curved arrow, but most of the time you're going to see 2 arrows, and here's the reason why. But before that, who's a nucleophile? If you look at the product, looks like this oxygen right here. Right, this oxygen, we got an alkyl group and a hydrogen, an alkyl group and the hydrogen. So that oxygen, this is an alcohol. This alcohol attack that carbon in the middle, you know. So your nucleophile is right here, and the electrophile, of course, for carbon in the middle, really electropositive there. All right. So nucleophile attack electrophile. Draw 1 arrow there. Now you're gonna realize that carbon is gonna be over octet. Right now, 8 electrons. 1, 2, 3, 4, 8. So 4 bonds, 8 electrons, right? Forming a new bond, that's going to be 10 electrons total. But that carbon cannot hold 10 electrons together. It can hold only 8, right? Because that's all orbital that they have. So you need another arrow. Break the pi bond, and this 2 electrons on the pi bond become a lone pair on oxygen right there. 2 lone pair here, 2 lone pairs become 3 lone pairs. Yeah. And when you draw it like this, the second arrow right here show bond breaking of the pi bond. So you show that. And a bond formation right here. That's from the first arrow, bond forming. That's the reason why oxygen from 2 electrons got only 1 electron. Now 2 lone pairs got only 1 lone pair left. All right. Okay. All right. Let's take a look on this mechanism. There are 2 steps here. So identify the nucleophilic attack step. Which one is a nucleophilic attack? Totally the first one. A nucleophile, right? Highly negative charge. That show you that's a nucleophile. Electron rich area. All right. Attack that carbon right here next to the oxygen. So that makes sense because it's going to be electropositive. This is your electrophilic center. Attack this carbon here, well, become over octet. So you need another arrow. Push this arrow down. This carbon is going to be over octet. Push another arrow down. The nitrogen is going to be over octet. So push an arrow down up to oxygen. That's the reason why this oxygen get electronegative, become negatively charged. All right. So if you look the whole step here, what's the overall what happened? Negative charge on this oxygen is transferred all the way here. We up to this oxygen right here, got a negative charge there, right? The negative charge become neutral right there. All right, that's the first step. This is a nucleophilic attack. Nucleophile attack an electrophile. Now let's take a look at the second step, the second pattern number 2.